This lesson is solving systems of linear equations. We've already done graphing systems of linear equations to find the solution, the intersection. And remember, we had three results. We either got 1 point, we got no solutions if the lines were parallel, or they could be the same line and the entire line is an infinite set of solutions. What we're going to do is another method. We're going to talk about substitution. This method will be where we algebraically solve for the solution to the system. So first of all, let's talk about the steps for substitution. So our steps for this are, number one, we're going to, because our objective is to solve the system, we want to get x and y both. So the first step is to get one of the variables by itself. So get one variable by itself in one of the equations. Now the second step, you want to then take that variable, it's going to be x or y equal to some expression. You want to take that expression and substitute it into the other equation. So whichever equation you were working with first, go to the other equation and substitute into it in order to get all the variables in terms of either x's or y's. You'll no longer have the second variable. And then the third step, you're going to go ahead and solve that, and then you're going to repeat. Until you get the second variable, because you want both x and y for this, or whatever your variables are. Your variables could be other letters like a and b, for instance. So on this, we're going to go ahead and take a look at this one and demonstrate it, and then do a few more examples. If you notice on this one, we've got already step one taken care of. Y is all by itself. X is on the other side with the rest of the expression. So we're going to take this expression that y is equal to, and we're going to substitute it in here. That idea is y is going to come out of the other equation, and what will take its place will be the 3x plus 10. So how this will look is I'll have x plus, and wherever I'm substituting that variable that's coming out, I like to put a parentheses in the place of it to know that the y has come out, and this 3x plus 10, since it equals y, it can go in its place. Whatever it's equal to can go in and substituting. Now I've got an equation that only has x's in it, so I can now solve that equation for x. So I'm going to have x plus, now distribute, so 2 times 3x is 6x, and distribute to the other one. So 2 times 10 is 20. So now x plus 6x is 7x. Now I'm going to subtract 20 from both sides to solve this equation. And so I'm going to get 7x alone over here. No more numbers. The constant's gone to the other side. -1 minus 20 is -21. So I'm going further negative. Divide by 7, and you get x equal to -3. Notice that we were able to substitute into the other equation and then solve it for x, but now we still need y. We're missing the y, so we're going to go back over here to repeat, take one of the two equations. You could pick either one. It's really your choice as to which one you think is easier. And when I look at this, what looks easiest to me is if I've got what x is, I use this first one and I could just substitute into that equation. So if I take y equals 3x plus 10, the first equation, and take this -3 and substitute it in, what I end up getting, take out the x, put in the -3, and then I go ahead and solve that. Plus 10 here. So So I get negative 9 plus 10, and negative 9 plus 10 is equal to 1. So when I put my x and y together, my solution for the system is negative 3, comma 1 for an answer. So let's follow these steps and do a few more examples. So we're going to solve for both x and y in this one. Notice in this one, neither x nor y are by itself. We have to do that first step to get one of the variables by itself. It's your choice as to which one you're going to do. Now there's probably some better possibilities here than others. Like here, if I add y, x will be by itself. Or here, if I subtract 2y, x will be by itself there. You have to just choose one or the other. So I'm going to choose the first one and add y to both sides. And so I'm going to get x equal to 5 plus y. And I add y to both sides. Notice x is by itself. I can now take this expression and I can substitute it into the other equation for the x. So where there's an x, I'm going to put a parentheses. X comes out of the equation. What goes in its place is 5 plus y. Now I can simplify this side. The parentheses just tells me what that quantity is, but now I can go ahead and add these because it's addition. So y plus 2y is going to give me 3y. Then I'm going to subtract 5 from both sides. So I get 3y is equal to negative 9. And now I'm going to get rid of the 3 by dividing both sides by 3. The inverse operation, 3 times y, we'll divide by it to get rid of it. So y equals negative 3 divided by negative 9 divided by 3 is negative 3. So it's my y value. Now I still have to go back and get x, meaning I got to go back to the original equation and pick one of the two. I could pick the first one or the second one. Since the last time I picked the first one, this time I'll pick the second. You can pick either one, it should work. So I'm going to make this x plus 2 instead of y, I'm going to put a parentheses, equals negative 4. And what goes in the place of that y is what y equals, negative 3. So x plus negative 6 is equal to negative 4. Add 6 to both sides, it's a negative 6, so if I add it, I get rid of it on this side. So make sure you do it on both sides of the equal sign. That's our golden rule of algebra, is to add, if you do one thing to one side, you got to do it to the other. So I'll just have x over here, negative 4 plus 6 is equal to 2. So my solution will be 2 for x and negative 3 for y. Always list it x comma y. Even though we solve for the y first, we want to put the ordered pairs in alphabetical order with the x first, y second. If our variables were a and b, we put a first, b second. All right, let's solve this one. Now this one's going to have a little twist to it that will add some information to you, just so you're aware. Remember, when we solved equations graphically, there were 3 possibilities. The first 2 examples we've done here were when we had 2 lines that intersected and crossed at a single point, and we got the single point solution. What if it's no solution because they're parallel lines, or they're the same line? You get infinite solutions, meaning you get the entire line as the solution. Well, let's take a look at this one and solve using substitution to see what happens. So you want to get x or y by itself. So this one would be a little harder because I've got numbers in front of the x and y. If you had to, you could still do it by subtracting one of them and then dividing by 2. But at this one, the easier one is to get this, one of these 2 by itself. So I'm going to go ahead and subtract x from both sides on this one. I could have subtracted y. Either one will work. So if I subtract x, I get y equal to 7 minus x. I'm going to take this 7 minus x and it gets substituted in the other equation. Make sure you go to the second one, not back to the first. The second equation and put in for y. So I get 2x plus 2 times out comes y. In its place goes what y is equal to. That's what substitution is. Now I'll distribute through to both of these. So I got 2x plus 2 times 7 is 14. 2 times negative x is negative 2x. Now I'm going to solve this equation, but take a look here. 2x minus 2x on this side, the x's are gone. I'm left with just a 14 on this side, and I'm left with a 2 on this side. Now, something's wrong with this because no variables, I can't solve for x or y here, and the statement I have, 14 is not equal to 2. That's a false statement. What you have to recognize is when that happens, that means that there's no solution. When you come up with no variables and the statement you have with the numbers is a false statement, it means that the lines were parallel and that there's no solution. So let me summarize what you can do for the possibilities. Remember, if you solve it and you come up with an x and y, that's the intersecting ones, you get a single point. That's okay. But what about the two cases, okay? This is a special note, special case. So we'll call this special cases. The special cases are when you solve, all the variables are gone. So no more variables in the statement like this 14 equals 2, okay? All right, so if you solve and all the variables are gone, there's two cases, okay? The first case is when you have a false statement, that means no solution. That, if you remember back to graphing, that means that there's parallel lines. All you'd put in the answer blank is that there's no solution. They don't intersect. Okay, if it's a true statement, let's say that when we solve this, the answer came out as 2 equals 2, which is a true statement, but no variables. That would mean that you would get the entire line as the solution. The entire line is the solution. In fact, what you do is you list one of the equations in the answer blank for that. This would be the same as when we did this graphically, it's the same line when we graphed it. Okay, I'm going to put a box around this. This special case here will be something that you need to get to know when this happens to pop up and you don't expect it. So most of the time you're going to solve by substitution, where you use your 3 steps in order to do it. Get the one variable by itself, substitute into the other equation, solve and repeat till you get both ordered pairs. But if you run into the case where the variables disappear and you get a false statement, that means no solution. A true statement would be the same line, meaning the entire line is the solution.